In our next example, we're going to look at finding surface areas of composite three-dimensional figures. Okay, so we're given this three-dimensional figure right here. It looks like, to me, it looks like it's a right rectangular prism. I'm going to assume this lateral edge and this base edge here are perpendicular. So I'm going to assume it's a right rectangular prism, and I'm going to assume that we also have a right, go ahead and just kind of make this axis here. I'm going to assume that this is a right cylinder as well. Okay, and so we want to know the surface area of the entire thing. Okay, so I'm going to kind of split this up into two sections here. I'm going to say this is the surface area of, I'm going to call it, let's just say rectangular prism. Okay, and on the other side of this thing here, I'm going to write, this is going to be the surface area of our cylinder. Okay, and we're going to find basically the surface area of both of these. Now, one thing we have to actually keep in mind is that this part of the cylinder, this base of the cylinder, we are not actually going to count as part of our surface area, right? It's not like on the outside, so we're not actually going to count that part as that base sits on top of one of the bases of our right rectangular prism. Okay, and so we have to keep that in mind, and we're going to kind of do something to adjust for that right at the end. Okay, so let's look at our surface area for the rectangular prism here. So we know that the surface area is going to be equal to the perimeter times the height plus 2 times the area of the base. Okay, and so this is where we're going to start. All right, now we're going to basically, let's find the perimeter here first, right? So the perimeter is just going to be 2 times 9, right? So 2 times this edge right here, this is 9 and this is 9, okay, plus 2 times 4, right? Because our other edges are both 4 of the base, right? So this is kind of what we get to start, right? So that will mean our perimeter is going to be equal to 18 plus 8. So our perimeter is going to be equal to 26 centimeters. Okay. Now our height is already given, right? Our height equals 5 centimeters. Okay. And so all we have to do at this point is plug this into our formula. So we get the surface area is going to be equal to our perimeter, which is 26. Okay. Multiplied by our height, which is 5. Plus, I'm just going to go ahead and put this in parentheses here, plus 2 times the area of our base. Okay, well the area of our base is going to be 9 times 4, right? It's just going to be base times height. So the area of our base is going to be equal to 36 centimeters. Okay, so I'm just going to go ahead and plug 36 into our formula here. All right, now as we continue, okay, we'll find that I'm just going to go to my calculator and get 26 times 5 is going to give us 130. So our surface area is going to be equal to 130 plus 2 times 36 is 72. So 130 plus 72 is going to give us 202. So our surface area is going to be equal to 202. And we're going to write this as square centimeters. Okay? And so we're going to start off with this. So I'm going to go ahead and circle this part. Okay, it's going to be a large part of our calculation. Okay, and now I'm just going to go ahead and continue to find my surface area of my cylinder. Okay, and so my cylinder, my surface area is going to be equal to well, the circumference, which is 2 pi r multiplied by the height. Okay. And then plus 2 times the area of the base, which is just going to be pi times radius squared. Okay, and so my surface area, I'm going to plug in all the information that I know from this picture. Okay, well, 2 pi r, so I'm going to say this is 2 times pi times our radius of 2 multiplied by our height of 3 plus 2 times pi times our radius of 2 that is going to be squared. Okay, so now our surface area is going to be equal to 2 times 2 times 3. Okay, that's going to give us 12 pi plus 2 squared is 4. 4 times 2 is going to give us 8, so that's going to be 8 pi. Okay, so if we just kind of combine like terms here, we're just going to get that our surface area of our cylinder is going to be equal to 20 times pi, and we're going to write this as square centimeters. All right, so that's definitely a good start here. So now we have to kind of figure out a nice little formula here for the rest of what we're going to do. Okay, so a good formula for this, or is basically the entire surface area is going to be equal to the rectangular surface area plus the cylinder surface area minus, and this is the part where we have to take into account this blue base up here. Well, that blue base is not going to be part of our rectangular surface area, and it's also not going to be added into our cylinder surface area. So we actually have to subtract 2 times the area of the, or the surface area, or 2 times the area of the cylinder base. Okay, and what exactly is the cylinder base? Okay, well, I'll just write this base of cylinder. Well, it's just a circle, right? So the base of the cylinder is just going to be pi times radius squared. So it's going to be pi times 2 squared, which is actually just going to give us 4, right? So 4 pi, right? So our base is going to be equal to 4 times pi. Okay, and so at this point, we're just going to plug in what we know, right? So we're going to say that our rectangular surface area was 202 square centimeters. So we'll say our surface area is going to be equal to 202 plus, I'm just going to write 20 pi as an approximated decimal at this point. So 20 times pi is just going to give us, I'll call it 62.831. Okay, and then minus 2 times the cylinder base area, which is 4 pi. Right, so 4 pi is actually going to be about 12.566. Okay, and so if I plug this in, this should give us our entire surface area of our composite figure. So this will mean now our surface area is going to be equal to 202 plus 62.831 minus 2 times 12.566. And this gives us, we'll call it 239.7. Right? So the surface area is going to be 239.7, and we have to write this in square centimeters. All right, and this is just going to be our final answer.